Hello everyone, welcome to my channel and welcome to another video on integration. If you're new to this channel or you haven't yet subscribed, please support us by subscribing. In this video I have one integral to look at. It's the integral of e to the power square root of x dx. Now how do we approach this? Well, here is how we approach it. Taking us to the first page, page 1. It's the integral of e to the power square root of x dx. Right, so we're going to let t squared be equal to x in the numerator there. In the power of e, the power of e, you can see that we have a square root of x there. So if we let t squared be equal to x, that simplifies the power or exponent of e very nicely. We obtain two equations from this one here. The first equation is to solve for t. So solving for t, we take the positive square root on both sides. T will be equal to the positive square root of x. The second equation is to differentiate both sides with respect to x, and what we get is derivative with respect to x of t squared. The answer must be equal to derivative with respect to x of x. That equation, remember. And here we have to use chain rule. Differentiating t first, we have 2t, and then we have dt dx. Remember, we multiply the power and then reduce power by 1. So 2 times t and then to the power 2 minus 1, which is just power 1, as follows, like so. So on the right hand side, what do we have? The derivative of x with respect to x is just 1. Multiply by dx both sides, we get 2t dt is equal to dx. Nice. Now this integral then, it can change as follows. It will be the integral of e to the power square root of, remember, x is t squared. And instead of dx, what am I supposed to have? I'm going to have this expression here, 2t dt. Fantastic. Now if you check in the power there, the positive square root cancels that, and what do we have now? What we have, if I may squeeze it in down here and taking 2 out because 2 is a constant, we have 2 times the integral of t e to the power t dt. Right, your guess is as good as mine. We have to use integration by parts now, and I'm going to let this integral be equal to I. So we can simply say that this is equal to 2i. I have to work out what I is. That's where integration by parts comes in. So we're going to say now I is equal to the integral of t e to the power t dt. Now we're going to let u be equal to t on one side. On the other side, we're going to let dv equal to this part here, e to the power t dt. On the left, differentiating both sides, you will agree with me that we just have du is equal to dt. If I may cruise, on the right hand side, we are supposed to integrate both sides. The integral of dv will be equal to e to the power t dt, and integral of that. You'll agree with me that on the right hand side we just have v. The integral of e to the power t is just e to the power t, of course with respect to t. Integration by parts formula says the integral of u dv equals uv minus the integral of v du. Now notice this part here is just t integral of t e to the power t dt. So this is the integral of course it's our I, is equal to the integral of t e to the power t dt is equal to uv. What is u? U is t. What is v? V is e to the power t, minus the integral of v is e to the power t, and du equals dt, as you can see. And yes, this is t e to the power t minus e to the power t, and I have to say plus c, because we're dealing with an indefinite integral here, plus c. Now we have to revert to our original variable. But before we do that, we are mindful of the fact that we have 2i there. So we can say, therefore, our integral, which is e to the power square root of x dx, must be equal to 2i, which is 2 times what is I? I is t e to the power t minus e to the power t, and then I'm going to put c there at the end. You can, yeah, it's a constant, so you can put it there. This is page 2. Let's go to page 3 to just finish this off. Now, let me put these papers in order. Right, here we are. This is page 3. Now, what are we saying? We're saying we have to simplify that, remove the brackets, and what do we get? We get 2t e to the power t minus 2e to the power t, and then plus c. But what is t? Well, if you go back to page 1, I believe it's page 1, remember the relationship between t and x is that t is square root of x. So I'm going to say this is the same as 2 square root of x e to the power square root of x minus 2 e to the power square root of x plus c. Now we can factorize this part here to 2 e to the power square root of x, open brackets, square root of x minus 1, and then plus our constant c. So this is the final solution to our integral. We take you back to our original integral that we looked at. This is the integral we have been working on. There it is, the integral of e to the power square root of x dx. And what is our final solution? Final solution on page 3. There it is, 2 e to the power square root of x, open bracket, square root of x minus 1, and then plus c, because our integral is an indefinite one. There are no limits of integration, so you must always remember to put a constant there at the end. Right, this is where I'm going to stop in this one. If you're new to the channel, like as I said at the beginning, if you're new to the channel, support us by subscribing. We truly value your subscriptions, your support in terms of sharing of videos and providing your feedback. It helps us quite a lot in how we present information on this channel. Right, I'll see you in the next one.